Good afternoon. I'd like to thank everyone for joining us today for the BuildX Alberta Virtual Education mini-series. For those of you that attended yesterday's session about data visualization and workflow efficiencies, I hope you enjoyed the presentation and the excellent breakout that followed. If you didn't catch that session, it will be available on demand shortly. My name is James Wyatt, the Programming Manager for the BuildX series from Informa Connect. Firstly, I'd like to thank our sponsors for this week's event, Vectorworks, the series title sponsor, session sponsors Intuitive, Gasonic, and Vectorworks, and our commercial sponsors, Initech, Windows and Doors, and PM Science. Without them, this mini-series would not be possible, and invite you to check out their websites and social media profiles. Now, before we start, you may submit your questions in the question box throughout the presentation, and these will be viewable by the speaker. Please use the same question box for any technical or platform-related questions, and we'll be glad to assist you. Additionally, there will be a Q&A breakout session on Zoom directly after this session at 1 p.m. Mountain Time for 15 minutes. You may join this session to ask questions or continue the conversation through text, audio only, or video. It's completely up to you. Lastly, I'd like to introduce our speaker for today's session, Kay Shumugam, Founder and Chief Visionary Officer for Gasonic Group. Kay has an engineering degree from City University in London, England. He founded Gasonic Instruments in 1985 to service a growing need for hazardous gas detection and indoor air quality monitoring in commercial buildings, mainly underground parking garages. In 1995, he founded Enviro Rentals to rent environmental testing instruments for both indoor and outdoor environmental consortiums. In 2016, he founded EnviroLight Retrofit and Recycling, which is a social enterprise under the Gasonic Group, to introduce zero waste and circular economy recycling systems for mercury-filled fluorescent light bulbs. In 2020, Gasonic celebrated their 35th anniversary, and at the same time, the pandemic helped Kay recognize a new vision for the company and pursue a new strategy of flattening the curve of inmosphere pollution, which leads us to this presentation today. Without further ado, I'd like to hand it over to you, Kay.
Okay, so thank you, James, for this really great introduction. Thank you, audience, for being here. I know it's really warm in Calgary, probably record temperature, and it's probably cooler in your house anyway. So hope you enjoyed this presentation. I will answer all questions you have. What do we need to do? Why we do things like that, and how we do it. And I'll be factual. In the age of alternative facts, I think it's important to say upfront, I'll be very factual. Very transparent, you can ask me any questions. I'll present innovative solutions, and I'm fully aware of where the building industry is, and I'll be very cost effective in my presentation. So let's start with the why. I like Simon Sinek. He says, people don't buy what you do. They buy why you do it. And what you do simply proves what you believe. And that's big in my world. Now, why am I so passionate about clean air now? Is I was born in clean paradise. Mauritius, which is a little island off Madagascar. If you go to look at it, it's only 60 by 40 miles. And therefore you'll have a hard time finding it. But look at the dot of Madagascar. And Mark Twain said that, at least. Now, as James said, I went to City University in London, and when I got into London, it was always grey sky. It's something I really felt always kind of depressed about, and I never knew there was anything wrong with the air, but it just was a depressing situation to see the clouds all the time. And I'll show you how we'll destroy all this myth. I came to Calgary in 1981, and the first time I saw the mountains, saw the city clearly from the plane, I said, I've landed in clean air, although I wasn't concerned about that at that time. So, but it's always been clean to me. So anyways, I will show you all this myth now is far away in history. So I came to the land of golden opportunities. A lot of people come to Calgary for that. And I've spent the last 40 years, funny enough, detecting air pollution. So I come from a very clean air environment and end up going to places where there was pollution. And for 35 years, obviously, I've done it for Gasonic. But I did it for another company before that, more in the industrial area. Now, most Canadians will not look at this picture and say, this applies to us. 9 out of 10 people worldwide breathe polluted air. It's from the World Health Organization. And most Canadians I've ever talked to says, that's a foreign problem. Have you ever been to China? Have you ever been to India? That's what we call pollution. And pollution, unfortunately, is invisible. And therefore, we don't know it's there. Sometimes the visible become invisible. And then we realize, oh, that was pollution. Now, why should we care about clean air? I saw this from 2 guys that's selling these bottle of air to China and so on. And I called them up and I said, look, I'm sure you build this company, but not to sell it to Canadians because we don't want to be polluted. And the guy said, yeah, but we want to sell it to China where it's really polluted. And I said, please send me 50 of these bottles. I'll buy 50 bottles from you, and I'll think of a way of trying to tell people that air has to be clean. That's very important. In fact, here's a bottle of air, and this is what people do to breathe air. I'd like to say all of us has to understand that pollution has to be controlled, or our kids will have a bottle of water in one hand and a bottle of air in the other hand. We don't want that to happen. Now, it's a myth that we've got, the mountains and hiking places and all the rest of it. There was a British newspaper, The Guardian, actually wrote this article that says, the great indoors. Us as Canadians spend a lot of time indoors. I mean, the cold weather for one thing. And, we end up spending a lot of time indoors, obviously with the pandemic, even more time indoors. And it's probably 90%. Now, I see some people, I've talked to some people that work downtown, and they tell me they go from their garage to the garage of the office, they take the plus 15, and I say, you don't take a breath of fresh air for months? And they say, I actually don't. And so we're taking fresh air for granted, but and we don't spend enough time outdoors. Now, how did we get here? This is a building, Gulf Canada Square, the first building that was really energy efficient. And it was the fact that we had an energy crisis in '73. We started in the 80s, especially, to really think about buildings, closing them up. So first thing we did is no open windows. You cannot get a breath of fresh air in a building anymore. It is delivered to you. It is conditioned with the right temperature, and hopefully most of the pollutants has gone. But obviously, we needed to ration air. Imagine that. And therefore, it was expensive, and we had to do it through a mechanical system. Now, when I started in business, I keep hearing, I was in the gas detection business, and I keep getting calls from people. I've got people that says they're sick, and it was called at that time sick building syndrome. And we must have spent 5 years. I attended university extension courses about air quality, the sick building syndrome. And, it was rather complicated. Like, what's affecting us? What chemicals was affecting us? Was it the carpet? Was it the glue? Was it any of that? And it was so difficult. And we need almost like a doctor. And sick building syndrome is not something that the industry will take lightly. As soon as you put sick to it, it's like having bed bugs in a condo. And so they had to find a different way. So ASHRAE, Association of Refrigeration Engineers, decided they're going to do some research and came up with a book that says Ventilation for Acceptable Indoor Air Quality. And that was easy because you could take one measurement a lot of you know that CO2, it's always in the news about outside CO2. And you can see on this graph, if you can see it, it's 4.7. That was actually the CO2 level a few years ago. It's now higher than that. And so you could take a CO2 monitor, you could measure the air inside of a building, and it automatically gives you essentially how much fresh air you're bringing in. And therefore you could deal with the complaints. And it ended up that through research, they found out at the time, that was 20, 30 years ago, that they found out that if you kept the level of CO2 below 1,000 parts per million, so 700 at that time was 600 something above the outside rate, you would keep everybody happy. And that's what it was. You asked your mechanical company to deliver a little bit more fresh air. And that solved a lot of problems. I mean, fresh air is very important, but 80 to 90% of it is recirculated because we need it. It's expensive, and we need to really deal with that. And what I learned here apply after COVID, after we locked down for 2 months, I decided that I'm not going to look at energy. I'm going to turn my fans on as soon as we get into the office and keep it running. My electricity bill just doubled, but it helped out. We don't have an issue. So that was how we solved the problem. And then we decided to go green, of course, building construction using lead, and we had bronze, we had silver, we had all of that. And it helped tremendously because now we're using material that would not off-gassing. We were using CO2 monitors in some cases to deliver air in buildings based on occupancy. So if you had a conference room or you had a schools would be a good example. You could essentially bring more air as you get more people in. But you really didn't, had open windows, or you really control the air at the same time, because that's what energy efficiency is. And we built over the time. I came in the time of the boom, and essentially you could see cranes over Calgary building the same way, glass buildings without any windows. And the air got delivered. Sometimes the air got delivered from the top of the building, which was okay. Sometimes it got delivered next to maybe a bus stop. I know one of the buildings, I had complaints on that. So if you take the air from the alley or from from a place where there's a bus, there's always complaint inside the building, because now you're bringing what we call fresh air, but it's not quite fresh. Now, what we did in Canada, of course, everybody I talked to, and when I show the picture of Mauritius, everybody says, "Why are you here?" And I don't like the weather, like everybody else that comes here. But so we all wanted to be comfortable. We all want to be able to basically park our cars inside. And so every office building I know that was built after the 80s have an underground parkade. And essentially every condo that we built now has an underground parkade. In fact, you'll be surprised to know that I've traveled a lot of places in the world, and we have the most attached garages and underground parkades than any place in the world. I've been to Iceland, I've been to Norway where it's cold, and I haven't seen a lot of closed underground parkades. So a lot of parkades in some places like Las Vegas has obviously got a lot of parking, and everything is open, if you notice. But here we wanted to close it. First of all, we have a situation where it's cold, and we have to take the air out, 100% of it, because it's contaminated, and we have to heat it up. So essentially, that was a lot of energy. I could imagine that if you had a 10-story building, and in the parkade you had to remove all the air, and the rest of the building, the 9th story, you can recirculate 80% to 90% of the air. The parkade is a significant amount of energy. So therefore, what they did was to say, hey, let's throw in a CO set in there. Let's control it, and therefore everybody's happy. So I used to talk to people, and they say, it's an invisible threat, CO and exhaust gases. So they'll say, I say, how do you know your system works? They say, well, I hear the fans once in a while. And so it became a myth that everything was okay because the fans were on once in a while. And the building code essentially came up and says, if you have a closed garage or parkade or a place where your car is repaired, for example, which is a different situation because now you've got workers that are protected by occupational health and safety, but they use the same technique. You would limit the concentration to 100 parts per million. And I don't know where that comes from. It's got no relationship to health. It's got no relationship to air quality and so on. So essentially, they pulled out this number out of the air, I think, or something, and said, let's throw in a number and people won't die, and put us a certain level, which turned out to be good breathing levels, so that's good. But imagine if you have, a kid, 2 or 3 feet up, the air he breathes or she breathes is different, right? I would definitely not take my dog in a parkade because the dog is breathing very low and exhaust pipe are almost at his level. So we solved the problem just because we didn't get any complaints and we didn't really kill anybody. We sent a lot of people to hospitals, and it was a bit hush-hush because a lot of it don't get into the news, but that's how we solved the problem. And I was fine selling detectors and calibrating it, which was like really harsh. And then one day I went to Canada Place in Edmonton. At that time, I was doing some of the calibration, especially out of town. So I got into Canada Place. I finished my calibration about 4 or 5 o'clock, if I remember rightly. And I was just about to return the keys, get back into my car, and I see a lineup of cars. And I realized that the theater had finished opposite that building, and everybody was going at the same time. So they had a tenant taking money at that time, and therefore it basically had a lineup. So I said, I'm going to have supper, an early supper, and I'll come back to my car. So I reparked my car. And when I came back, there was people being taken to a hospital through ambulances. And I don't know how many people, but there were several people. And they opened the gate, let everybody go. And so that was a lucky escape. But I was really not happy with that. So I thought, I'm doing something. I have a CO detector, and I could see the CO detector showing red alarm. And yet, I had no choice. I had 2 choices, essentially. Save myself in some ways, or go frantically in front of the windows of the driver and say, stop your car. And I knew that would be difficult, and maybe, somebody won't accept that. And therefore I said, no, I'm not going to chance that. And therefore I left. And this is the result. And I got so fed up, and I said, the canary actually saved thousands of miners' life in the 1800s and was used till 1930 or 40 or something, was still being used. And the canary saved a lot of people, a lot of miners. And it had 2 advantages. It actually could detect CO better than any sensor at the time. Plus, it communicated with people. And what we had done with CO detectors in parkades, exhaust gas monitoring, more specifically, is that we essentially didn't tell the people that there was a dangerous situation. So I said, bring back the canary. Maybe the canary would do better. I took a canary, I took some pictures, and while I was doing that experiment, the canary actually detected exhaust from the level below and went into a bit of a stress and flew down the cage. And I realized that, yeah, the canary is very sensitive. So eventually I didn't want to own a canary. I don't like, birding cages. So I returned it and got 50% of my money back. But when I had the canary at home without the stress of driving, and I put it outside in the warm weather, and it started singing. So I took that phrase, "let the canary sing," as a metaphor for better gas detection. So I went on a search for a better sensor. Can we find a better sensor, first of all? We can use electronics to process it and have a better equipment, but it's like garbage in, garbage out. You couldn't do anything without a better sensor. It had to be specific to CL. Other sensors were reacting to everything. It had to not react to humidity. In a parkade, they build something and they say, oh, it's okay, it's 20, 30% humidity, whatever the range is. But in a parkade in the winter, you have snow coming on cars, melt, and essentially you have now water in the parkade floor, which actually increased the humidity. And I went in parkades where the fans were running all day just because of humidity, not of any exhaust gases. It was accurate. It had to be accurate. And the sensor that we looked at, we're talking about 1 part per million instead of plus or minus 100 parts per million. The main thing in any building is that it had to be inexpensive, and therefore it has to be long life, because if it's expensive and you had to replace it, then you better have a long life on it. So that's the sensor we started investigating. I took both sensors, a new sensor, electrochemical cell technology. By coincidence, while I was at City University in London, I was in the electronic engineering department. And in the chemical department, they were developing the first electrochemical sensors that was affordable. Anything before that was really expensive. And as you can see on this graph here, I put ferrous stick, windshield washer. I put some humidity, and the black line shows you essentially the solid state sensor that went up to 120 parts per million. And oil, and I increased the temperature, and you still had a reaction. So it reacted to absolutely everything. Now, I put coffee on there. One day I was asked by the town of Banff superintendent. He says, can you come over and check my CO detector? I'll meet you at whatever parkade. So I drove from Calgary, got there, and he says, can you test my CO detector? I say, hang on. I'll take my coffee and I'll put it underneath there, and we'll see whether it goes off. And the sensor went off. He says, oh, come on, replace everything I have. And we end up replacing everything in the town of Banff. So that was interesting. I sold a gas detector using a coffee. Then I compared the sensor, because I had a call from an engineer when Calgary Parking Authority was actually building the James Short Parkade. They said, here was the criteria. Put in the best sensor possible. Cost wasn't an objective. You and me was paying for it anyways. And we'll see how it goes. I said, yeah, I can get you the sensor, but the sensor I was looking at would not last very long and would cost a lot of money to replace. So that's that sensor. So it satisfied everything. After a year, we went back, we put 100 parts per million, and it reacted almost exactly 100 parts per million, or plus or minus 10%. The solid state sensor, which was at Centennial, actually, building built in 2000, and we had gone back to solid state for that building because it was obviously competitive, and the sensor went all over the place. It either was very sensitive and it turned on the fans for too long, or it failed. And some of the failure was based on the fact that they painted the parkade, and the parkade was, it killed the sensors, right? So the solid state sensor just didn't perform. And I was really getting fed up with this now that I saw there was a sensor available that would work. The problem with everything is that it's the money. And it's also the design. The sensor we had put in Jim's shoulder, which are now being replaced as we speak to a better system, was just a sensor giving a signal to a building automation system. So I said, okay, I need somebody to design the sensor with the whole electronics or design it myself. And what I did some research, and I said, okay, I'll think about building it. And I didn't really want to do that. I didn't have the resources at the time. So I eventually found a company in Montreal called Vulcane. And I called them up and I said, do you have a sensor that would work better? And I spoke to a young engineer that was taking Guy Gervais, who was taking over his dad's company. And he says, by the way, I have the same feeling when I go in a parkade. I try to calibrate something, and I'm not happy when I come out. I'm just wondering whether I'm going to get a phone call later that somebody's been sent to a hospital. So knowing that he was hesitant, he was like having difficulty speaking in English. He was just learning English. And I spoke to him in French. And from that time on, we became good friends. And he said, by the way, you speak French better than I do. I said, no, I don't speak French every day. But he says, you've got a different accent. We have a Quebec accent. So that was just a fun thing we got into. And we had a long-term relationship until, and he came up with some units and then eventually sold his company. So the first unit he came with, I call the first electronic canary, because I was passionate about what the canary had done. He had the accurate sensor. It now complied to more stringent occupational health and safety rules. Most important, it had a visual, which was the bar graph, which was not quite a display. And it had that, at least to warn people. It had some other faults that eventually we tried to fix, but it was the first design that was actually accurate and you could depend on. And so we replaced it almost everywhere we could. We went on a bench of upgrading systems, right? Eventually, he sold his company to a company in Calgary, by the way, because they saw what we were doing and they went to them and eventually bought the company, which was eventually bought by Honeywell. And so Honeywell came up with this unit that what I call the perfect electronic canary, because it has the display, it has a loud alarm, and it has an accurate sensor. And a little story behind that in terms of how did I know I found the right thing. If you all remember, if you were here in Calgary, there was a big flood in 2013. And we had put a lot of these equipment around downtown. I got a call one day just after the flood. So the flood didn't kill or hurt anybody, but actually pumping the water out of the parkades and dozens and dozens of people to hospital because of the fumes coming out of pumps, gas-driven pumps. And so I got a phone call during the flood. 2 days after the flood, I just drove around with my little portable trying to see whether I could help anybody. There was a lot of Calgarians helping, so I did my little bit. And then I got a phone call from Chinatown, and the guy says, you know, I'm feeling a little bit bad. I'm pumping this parkade. I'm not feeling good. Your unit is into alarm. What shall I do? I said, please get out of there and wait for me outside. I'll be there in 20 minutes. And when I got there, the guy was sitting like he was really tired. And I went in the parkade, and the unit displayed exactly what my portable was. And I knew I found the accurate sensor. And I knew I helped somebody. At least I know this one. And there must have been other cases where we helped people by them looking at the display and saying, oh, it's not safe out here. So that was a good thing to have. So I went back to Canada Place, what I told you about where I had this incident, now saying, hey, by the way, I escaped an incident. It was probably 10 years before that. And I said, look, I've got a better system. I can show you that. And we can upgrade the system now and make it better. He said, no, okay, show me the money. It's all about the money. And he says, I am going to do the study myself, and I'll give you the data. So he said, this is what I'm going to do. In 1999, as you can see here on the blue line, he says, essentially, I'm not going to give you an order. I'm going to monitor my electrical consumption to my exhaust fan in the parkade. He had 2 to 3 level of parkade, if I remember closely. And he says, I'll just do a baseline study. And then I will get you to change 1 level, and I do the study again. And then the following year, I'll do another study. So it was 3 years that we had to upgrade. And as you could see, 2001, and this line that goes straight is basically said, I've had enough. I'm going to stop the experiment. You upgrade the system. So we upgraded the system, and this is what we found. It cost about $20,000 to upgrade, and we had $19,000 in saving of electricity. He didn't bother to monitor the gas saving because in a parkade like this, you would have to heat the air, of course, and his fans were running a lot. So we estimated $10,000. Then he had reduced calibration and reduced sensor changes because we had found the sensors actually last quite a while. So he was happy. He made his money back within a year or one cool heating season, the winter especially, and he was really happy. He had the money. And I had his data, which I was able to show a lot of people, and I came up with a figure, $50 worth of saving per parking stall. And when I approached building about this idea, it wasn't about health and safety, it wasn't about anything, it was energy saving. Remember, we had made our building energy efficient, and therefore we have to control the ventilation. Everybody was happy. We upgraded tons of buildings for quite a while, and essentially everything went well. And just showing that data, showing that graph, showing the drift of the sensor, everybody bought onto it, and it went, like I say, very good. But there was a turning point in the decision of the company. So if I wanted to make maximum money, a sensor that takes calibration 4 times a year at least, to me, it almost should be calibrated every month, is going to reduce the service costs. Do I go after the money, or did I find a technology that would help the occupants of a building? And I decided, the way I am and why I'm in business for, I jump onto it and say, let's upgrade, reduce the service department, less technician, but upgrade. Everything went well. So that's what we did for a number of years. And, not too many companies would do that because it's all about the profit at the end, but we did that. So during the next decade, we upgraded thousands of sensors for Western Canada, but mostly in Southern Alberta. And the saving today is $1 million of energy per year from buildings. You take Bankers Hall, I know we save them about $50,000, just one building. So we did a lot of buildings. So it was working for everybody. Everybody was saving money, and they were happy, less calibration, and they didn't have any, drift of the sensor that would keep the fans running. And so the fan ran probably 80% less. But I realized later I made a mistake. Like everything else in the world, you give money, like government gives money to businesses and the rich people, you can't get it back. And I wish I could have some money back to give more air to the actual clients that park their cars in the building. But hopefully we could do that. So the other thing that happened is now I was eating the lunch of manufacturers and competitors. So I had them knocking on my door. One of the guy coming from Ottawa and came with false pretenses. He says, "Oh, I'm thinking of buying your company. What are you doing?" I said, "Well, this is what we've done. This is a better sensor," and so on. And he went back, and 2 weeks later said, "Oh, we've found a way of upgrading our equipment with this sensor, just plug and play." And I said, "Oh, really?" And then he didn't have any intention of buying the company, just to come and see what we were doing. So he went away, and we kept on going. And then we had a service provider that came in and said, "What are you doing?" And we essentially said, that's what we're doing, and so on. And they basically offered to buy the company because they could change the calibration frequency up to 4 times a year. And I say that was a false sense of security. I don't want to do that. I want to really get systems that are working so people can have a safe environment. And it was something, maybe it was the lunch or something, but there was something in my stomach that said, no time to sell. I was at age that I could sell. But I said, no, there's something else I haven't done. And so, and what they did themselves, and we could talk about that some other time to people, but you probably notice a lot of buildings now, especially any parkades, especially the residential one, are starting to have nitrogen dioxide put into them, NO2 for diesel. And the building code says when the majority of vehicles are powered by diesel fuel engine, but manufacturers have found a way of putting dual sensors in and being able to sell a high price equipment and providing a false sense of security, because I don't think myself, I'm prepared to do some research, which I'm in the process of doing, whether diesel nitrogen dioxide sensors are really effective, because diesel is a different animal. It comes out as an NOx, which is NO2, N2O, and so on. So it's very difficult. In fact, where it says 3 parts per million in there, it doesn't work. We have to put it even lower, even in an area of a loading dock where there's a lot of diesel trucks. So we're going to conduct some research. Hopefully, we actually going to partner with somebody and actually see whether these things work. And I'll be happy to work with anybody on, really seeing whether that works. But so I put my business on cruise control, and 2018, 2019 was my year of reckoning. What I mean by that is this was the beach in Mauritius where I always, at least at Christmas, New Year, have some time on the beach. That's my only time that I try to go away and have something from back where I was before. I went back to Mauritius and now found something incredible. The beaches that I used to camp on, the beaches that I used to go to, was disappearing. And I got some data that although we think of sea level going up by little 1 inch or less than an inch, but when you're on a beach, you're actually losing 1 foot. So we've lost about 15 feet, and in 15 years, a lot of the beaches would be gone, because it's like the math, triangle of math, where, a slight rise would create, eating the sand. So I was sad about this, and I actually suffered something that I'm sure a lot of your kids are suffering right now. It's eco anxiety. A lot of people are feeling anxiety, and I came back and I tried to go to a meeting to talk about climate change, and I got eco anxiety. I got out of there and said, maybe I won't talk about climate change. I have to find something else. And after that, during the pandemic in 2020, now we had a big ship wreck on the beach and actually pollute the sand, pollute the water. But the people themselves, when I went, had so many cars that the air was polluted. And I tried to talk to people. I tried to talk to a politician, actually, the president of the island. And I had breakfast with him, and it's a relation, not really. I call the president. He knows me. And I said, Mauritius is polluted. He says, no, Mauritius is not polluted. There's a gentle breeze to remove the pollution. I said, no, it's polluted. You've got traffic, it's polluted. Finally, eventually, he promised me his next car will be electric. So I'm waiting for that. So then, because it's a 24-hour flight to Mauritius, and I had to go 3 times in 2019 because my mother actually was sick and eventually passed away. And so I ended up in London several times. And if you're in London, fly over from Calgary or Mauritius, it's a really long flight, so you get tired. So I was going in the train, I saw this article that says, let's clear the air. I was too tired to read it, so I took it. And I found out from my research that air pollution killed 9,500 people in London. I said, wow, that's in the air over London. So there must be an issue that we haven't figured out. And that's why London was great. It was really pollution. But it happened a lot more since I left there. For the last 4 years, I've been in Canada because of the increase of engine, especially diesel and so on. So, but in London, the event that really changed it is this girl called Ella Adukisi Deborah. She died, and her mother fought for her, and eventually it was written on her death certificate that she died of air pollution. And now everybody knows that there has to be changes. So in 10 years, if you go to London, all the buses would be electric, all the taxis would be electric, and the air would be a lot cleaner. Would it need to take a death to change things? Sometimes, unfortunately, that's the way we operate. We have to be pushed. But London is well on its way to become a cleaner city, for sure. And eventually there was an organization, when I did my research, Mountain for Lungs, and don't mess with the nuns. They go after the politician. They were, the mayor's race was on. They had a new mayor in London, which was the old mayor that was there, got the election, but he had to deal with air quality. And he decided he's going to put 50,000 car chargers in London. So there'll be something good coming out of this. Now, Mum for Lungs really got me to think about this. On your left is the Mum for Lungs no idling sign. And so I decided to start changing my idling sign. And I'd like to work with a lot of you guys because that's education we need to do for people in parkades, not to idle. Making the invisible visible is one of the major things we need to do. This is a bear that when the pollution goes up, it starts coughing. This is education for the public. And now you can do a high-tech way of doing it. You can go into London, find out exactly what the air pollution is over the city, wherever you're going to go biking and so on. So there is a lot of progress, and air quality is going to become a big thing. 2020 will be the year that every one of you remembers, of course, the pandemic, and hopefully we're out of it. Hopefully 2021 would be a good year for everybody. And will the world accept pollution? One of the positive things that we saw was how polluted the city was, which was visible, but we didn't think about it. And what happened after we locked down? The city sky cleared up. So will we accept pollution? Will we go back to normal? Or will we be pushed to make changes? Air pollution kills far more people than COVID-19 will ever. But 10 million, I've heard figures of 7 million to 10 million, but even 7 million is much higher than the pandemic. So it's definitely higher than COVID-19. It is the other pandemic. And hopefully, after we go back to normal, some of us will be working on the next pandemic and make sure our kids will breathe clean air. Why is pollution bad for us? Pollution is an introduction of contaminants into our environment that can produce adverse changes. I mean, we should think of the other animals on the planet, but it's all about us. So we'll say it affects us. It could be noise, it could be heat, it could be light, and so on. And small dust particles is a major pollutant. I'll give you a couple of questions which we can answer later. Is carbon dioxide, CO2, a pollutant? Maybe not directly, but think of the definition that I've just said. Does it cause something else? Is COVID-19 a pollutant? Answers will come later. Now, the reason that we are susceptible to pollution is that actually we're not made up of very much. There's 118 base elements in the universe, on planet Earth, and we've sucked 60 of it, micro minerals like calcium, phosphorus, and so on. Most of our body is water and carbon, so 5% is those minute chemicals. Now, in our microbiome, so which is our gut and our white blood cells, we have a chemical factory that is perfect, that will fight 1 trillion invaders. So we messed with it. That's basically what we did. So when people says, I don't need a mask and so on, is pollution affecting the way you're going to fight disease? I think it is, because we don't know what the pollutant does. So what we've done is gone through this big chemistry experiment after Second World War and basically got the industry going, chemical engineering, and we produce 50 million new chemicals. Now, all of those chemicals, some of them would be neutral, some of them would be beneficial maybe for our health, so some of the pharmaceutical, but we don't know how many affect us. And what we've done is toxifying our body by surrounding ourselves on our skin, in the air. And with the air, you don't have any way of knowing, so you don't have a choice of breathing the air. You have to breathe. And you can bring a bottle of water if you want. Maybe you can bring a bottle of air, but this is not the life we want to lead. So the air, you have no choice. Now, a lot of people are saying, oh, I'm worried about COVID-19, where it comes from. What about the variants? What does it do? And I found this, Contaminants of Concern, BTECs. We have BTECs everywhere. We have BTECs in our houses. We have BTECs when we fill up because it comes from gasoline and so on. And it's been distilled in a lab. And if you notice, there's benzene and toluene. To give you an example, if we call benzene a variant of a chemical, it's 100 times more toxic than toluene. It's got a 1 part per million limit. So we created those variants. We are exposed to it. I'm not interested where COVID-19 comes from, because I'm thinking we should look at all pollutant, biological pollutant, chemical pollutant, and make sure we've got healthy air, and therefore we don't affect our immune system. Now, Health Canada, which I'm hoping, I've been in touch with them to try to, do some joint research on air quality in buildings, because I think this is the next pandemic, and we've got to look at it, or the current pandemic, if you want to call it. We just had a break during COVID-19, but they talk enough benzene found in attached garages can cause increased leukemia, and benzene is a nasty one, and we want to see whether we could eliminate that. So the universal right to pollute cannot be taken back, and therefore that's one of the issues we're going to be facing, is how do we reduce pollution? And that's going to be a big challenge, because nobody's going to accept to shut their car off. So what I did after the pandemic, we had 2 months, obviously, of lockdown. And I had, like everybody else in business, owners had to figure out a way of, making money and get paid back from what we lost. And so I decided I'm going to take my Tesla, put gases in it, and do calibration myself. And I found that the first thing I needed to do is change attitude. I didn't want to go in as a technician. I wanted to go in and ask a question. What is the air that people are breathing? What is it like? And I discovered some surprising things. People didn't care about idling. I saw people that was having lunch and idling their vehicle and listening to the radio. I heard of a lady that idled her car, forgot to turn it off, took a plane and left. And it took 30 hours of idling in a parkade. And I saw technology. I was standing next to a tailpipe doing a calibration, and I heard this engine go on, and a guy came out, and I said, "Why did you turn your engine?" He says, "Who are you? I own the building. I can do whatever I want." The other thing I found is that sometimes the alarm came on just because it triggered the alarm, and people were ignoring it. So that was a major problem. So I did 70 buildings in Calgary, 33 building in Canmore. But the good thing is I could go in, do some adjustment, came out, felt happy that I could have cleaner air for people. And I was able to upgrade a few buildings in Calgary, including one that I found a baby was left in the car. And I talked to the mother and I said, "The system doesn't work. Please don't leave your baby in the car while you go upstairs." And so she did that. So what I found, though, in Canmore, which was interesting, and that destroyed the other myth, is the fact one day I woke up and I said, "There's something wrong with the air in Canmore." I could smell something. During the pandemic, I stayed out of town and was not exposed to exhaust gases myself. I'd become oversensitive where now I could pick up exhaust gases. And I say to my tech, actually, who was there with me, I said, "There's something in the air." Pull out my CO detector. That was 5 ppm, town of Canmore. So although it's in the mountains, because it traps the air, and if you have a certain temperature inversion, the air over what I thought was clean air could sometimes be polluted. And so what I did, we've been doing is actually looking at lowering the level. As you can see, what I found was we accepting a certain level of pollution in the parkades. So if a car starts up, the level starts to slowly go up, and pollution is in there all the time. And we've discovered pollution within cars, inside of cars, because it has somewhere it needs to go. But what we're still investigating, we're still doing some research as we speak here, and just trying something. Lowering the levels, would that reduce the level of pollution in parkades? And we found out that we could do that. It wasn't as easy because you have to be careful of not keeping the fans running all the time. But further research has to be done, and we can optimize the ventilation system to do that. I was getting frustrated. We couldn't remove pollution from the parkade. And 2 weeks later, I got a call. Somebody says, "I came up with a paint from Italy that would actually reduce the pollution." And so we tried it. We built those 2 boxes, and this is the level with the control level, and this is the one with the UV light triggering the coating. So that's worked out good. More about that later. I'm sorry for the disruption we had. We're now going to go back to where I left off, and hopefully everybody can join us. Okay, so why pollution has to be removed from parkade as much as possible. I was called to this building in Eau Claire, and I was called to the penthouse because the people living in that penthouse could not stay there anymore. They felt sick, they had to move to a different building, and it took months to figure out what was happening. Eventually, we thought it was pollution, indoor air pollution, that was causing it. In the meantime, they had basically put their own ventilation system in the building. And as you can see from the animation, what they did was alter all the flow from the parkade into their suite. And so every bathroom fan, every car exhaust was actually going right through their suite. And it was a toxic soup of various things. So we ended up shutting down the ventilation system, and it works. So you cannot keep pollution in a building. We essentially live currently in two boxes. One box for a car and a box for our living space, but we have to be connected by an elevator because we don't want to go out. As a result of this, the air can move to any part of the building depending on airflow. So it's very important to check air quality from parkade to penthouse at times to solve problems. Now, we've made a commitment from what I've learned in the pandemic, going out and checking out 100 buildings or more now. I want to conduct more research. We've been in touch with Health Canada, and we would work in collaboration with them and try to find out what is the air quality like. How can we improve the air quality in buildings? And I'm very, very confident we'll be able to achieve cleaner air for everybody in buildings. Optimized ventilation system for clean air is what we're going to try to do. Work collaboratively with all stakeholders. Technology is not a problem. It's the attitude we take. And everybody after this pandemic has to look at attitude. Are we going to help each other? We're now being used to the fact that we take a vaccine to help the other person, not us. Are we going to do that in our building? Are we going to share things? And I'm prepared to do an educational campaign. I've started a YouTube video, several of them, and I'll be going out and to my customers and giving them this bottle of clean air and talk about message in a bottle. Does that tell you something? Do we have to deal with pollution? Now, the other thing that I've investigated over this pandemic is the last few weeks I've actually volunteered to go to places where they're cleaning parkades, because since 2001 we've sent probably in the area of 100 people just in Calgary to a hospital because of exposure to carbon monoxide and dust particles and so on during cleaning. That's the highest time for incident. And we want to solve that. We want to eliminate that. And I think we've got the technology to do that. Like I say, it's the attitude that we have to change. So everybody that runs a condo on a condo board, we've got to work together and put ego aside and say, how do we solve problems? And so I'm hoping we could do that. So we're going through this pandemic. It's coming to an end. And what we have to realize, I'm the baby boomers generation. And I'd like to talk to my baby boomers generation friends and say, the kids didn't go to school for 15 months. They did that for us. But they are going to be in a longer pandemic called air pollution. It's going to be all over the world. It's going to affect millions of them. So we've got to look at the next generation and say, how do we end the pandemic? And how do we end a pandemic? It's vaccine, vaccine, vaccine. In 2003, I decided to only drive hybrid vehicles. And the reason for that is that it doesn't pollute inside parkades. The engine gets cut off and it runs on batteries. Today, though, you've got to look at plug-in hybrids. They're coming in really fast. My son just bought one, and they're great, and they give you a little bit of electric, and you run on gas when you're on the highway. But take a look at zero-emission electric vehicle. This is going to be the solution for clean air, and it's obviously going great. The release of the F-150 truck electric will change the world in North America. So we've got to really look at that and go and shop for one. Go and look just like a vaccine. You spend a lot of time on vaccine. Which vaccine is good for me? Well, look at this vaccine. My preference, the best vaccine, is we can't all get into cars. We have 1.2 to 1.4 billion cars on the planet, with 85 million coming every year. We've got to look at a different one. And I've decided last year that I'm going to buy a foldable e-bike, stick it in my car, and bike. And this year, what I've done is I've actually put a little flag on it, e-biking for clean air, and I'm going to buy have my air bottle and stop me anywhere you see me. Let's have a chat. Let's talk about e-biking. E-biking can be introduced all over the world. It just takes probably one solar panel to power it. So, and it's good for my generation because I can't really get on a bike and going uphill anymore, but an e-bike would really help us. My top speed was 45K. I'm really surprised about that. And it's a lot of fun. You get to talk to a lot of people. So see you on the path, and hopefully we can have a chat about that. The future of clean air is electric. It might be hydrogen. Alberta is looking into hydrogen, but even hydrogen will go to electric. So we've got to look at that. That's the way it's going to go. And I teach a lot of kids about electric cars. In fact, today, if I wasn't here and there was no pandemic, I would be in front of City Hall teaching hundreds of kids about electric vehicles. And they are so excited. I've met only one child in 5 years that will buy a gas car. Most of them will buy at least hybrid or electric. So it's coming. And one of the things they're going to tell us is, you guys have your building. You've got us to not smoke. You put a sign in the building, non-smoking. You put a sign on it that says you're not allowed to smoke 15 meters from the building. But what have you done? You've actually taken your smoking machine inside the building. And the young generation would say this is not acceptable. We've got to deal with that. So there's going to be challenges, and luckily young people have developed the challenges. Unfortunately, you can't meet Glenn Gordon, but you can go to his website, Unico Power. What he's done is develop a smart charging system so we can share the electricity. And we are installing solar panel just above me here. And we've put a smart charging system that we can now distribute to the rest of the condo. This is going to be a public place where people can come and learn and show you how the future should be handled. There's enough power, but we got to share it. We can't all use it at the same time, and we can solve the problem. So all condos, all property managers, all property owners should start looking at charging. We need to do this. The future of clean air is looking at this and being prepared for a flood of electric cars that's coming. I've got a YouTube channel, and I'm running a 3-part series, The Invisible Enemy, Winning the Battle for Clean Air. The first part 1 is about the coronavirus. Part 2 is going to be very interesting. I wasn't playing golf this summer, which hardly I ever played, but I painted 100 golf balls and 10 ping pong balls just to teach people about the air and what's important. So I look forward for you to watch that, and you can watch how I converted an electric car and test your indoor air quality, an electric car to an air monitoring device, and you can see my zero waste fluorescent light recycling. If you get bored, just see why our dog Jasper, in Even Dogs Can Drive a Tesla, look at this. Now Jasper will never want to get out of the Tesla, and it's become the most expensive doghouse in the world. Anyways, have fun and ask me a question anytime. I'm available for meetings, lunch and learns, anything you like. I love teaching and I love solving problems. I thank you so much for your patience and being here on a hot summer day, but hopefully we'll meet and we'll talk more about this issue we have. Thank you. Now I'll answer a couple of questions that came up, and I asked a question about essentially whether CO2 was a pollutant. And CO2, everybody will point out, is not a pollutant. It's good for the trees. But the problem we face is when we have excess CO2, it causes another problem, which is heat. And today in Calgary we were almost record temperature, and it's CO2 in the air, which you'll see on my YouTube channel on the second part, is causing heat stress. And heat stress is a very major environmental issue for us. So CO2 is not pollutant, but in excess it causes issue to our body the same way as any other pollutant in some ways. Is coronavirus a pollutant? Well, in my Invisible Enemy Part 1, you'll see that it acts as a dust particle, and therefore it is a biological indoor air pollutant. And we do have biological indoor air pollutant already, from mold and so on. So we'll have to deal with chemical pollution, indoor pollution. We have to deal forever with biological indoor pollution. And therefore, we've got to deal with these issues on an ongoing basis. So indoor air quality is becoming critical after the pandemic.
Okay, thank you very much for sharing your experience, your passion, and obviously insights from years of experience in this field. I'd also like to thank our session sponsor, Gasonic Group and Vectorworks, who are our series title sponsor. We apologize for the technical disruption during the original production of this webinar, but I hope you've been able to watch the content in its entirety now. Please do share this. You should share your registration email with colleagues who would be interested in this session and others. They can register themselves to watch the session at their convenience on demand at a later date. We just lastly would like to thank you for taking part in the BuildX Alberta Virtual Education mini-series. Please make sure you're signed up to the newsletter or follow us on social media to keep up to date with new events from the BuildX series. And with all said, thank you very much. Goodbye.